Hi, good morning. In previous video, we have discussed about water sensor and water actuator and different types of transducers. Now we are going to discuss about an analog sensor the interfacing that comes under unit to microcontroller and interfacing techniques for IoT devices. What first we have to discuss about in general. Interfacing analog signals with Arduino is a common task for creating a project to measure and monitor various physical quantities such as temperature, light, sensor, pressure, and more. Analog sensors typically provide an output voltage or current that varies potentially and proportionally with a measured quantity, which can be read and processed by analog to digital converter like ADC built, which is built into the Arduino microcontroller, inbuilt in within the microcontroller. This is an example for us creating a dimmable LED using potentiometer to interface an analog values with the Arduino. In this program, we are dimming the LED based on the value read from the potentiometer. Potentiometer has a value ranges from 0 to 2023 dash. A zero value from a potentiometer is 0 volt and a value of 1023 from a potentiometer is a 5 volt, which means we need to write a value of 255. Hence, we need to scale our reads from the potentiometer, which falls between 0 to 1023 to a suitable right values to be between 0 to 255. Using the given formula, right value is equal to 255 by 1023 into read value, what we are reading it from the potentiometer. This is the circuit diagram for creating an LED using blinking an LED using a potentiometer. We are connecting the LED with the help of resistors and a potentiometer, and we have to give the power supply for this. And we have to create a program and in the Arduino. Then we have to compile it and upload the program into the kit. This is the program for blinking LED using a potentiometer. We have to declare the pot pin as A naught and LED pin. We have connected it in the ninth pin, and we have to read the value to store the value from the potentiometer and write the value to the LED. In write value means we have to write the value to the LED, either it is a low or high. Then we have a pin mode, pot pin as input, and LED pin we have set a variable of pot pin as input and that read from a potentiometer, and LED pin as an output to either it may be a low or high, and we are giving a baud rate of 9600 and reading value equal to analog read of pot pin. We have read the value from the potentiometer and from the pin of pot pin as then we have declared pot pin as an input, and we have to read the value from pot pin, and right value equal to that we have discussed in the earlier this formula we have discussed 255 slash 1023 into read value, and we have to write that value to the LED pin, and analog write equal to LED pin comma write value, we have to write it to the LED, and the LED we have to debug the purpose, and you have to compile that program. We are interfacing sensors to the Arduino board or we have different types of sensors, and we are interfacing temperature sensor, light sensor, ultrasonic sensor, and line sensor. These are the sensors that we have to interface to the Arduino. We are going to see about an interfacing a temperature sensor. LM35 is a temperature sensor, and the components required is the jumper wires and breadboard. LM35 is a temperature sensor or the series of gadgets with a pressure integrated circuits temperature whose yield voltage falls directly corresponding to the centigrade temperature, calibrated directly in Celsius and operates from 4 volt to 30 volt. Ranges are evaluated from minus 55 degrees Celsius to 1000 to 150 degrees Celsius, and it is suitable for remote applications and mainly used in battery management in industrial purposes. For interfacing this, we are using an serial peripheral communication devices. When device's S pin is low, communication happens with master. If S pin is high, ignore the master and a device sharing the same ISO, MOSI and clock lines as we discussed before in the communication protocols. To program and new SPI devices, key to be noted is the maximum SPI speed of the device use, how data is shifted from MSB or LSB. Data clock is ideal when high or low. Interface, this is the temperature sensor, how we are interfacing with an Arduino board. This is the program for interfacing a temperature sensor with the Arduino board. We have declared a temp pin as an input pin A5, and there will be a buzzer also will be there. If the temperature goes beyond, the buzzer gives an alarm. We have set that buzzer as an output pin.